Okay, so um, today I'm going over the zero product rule, and just as an FYI, I will often call this the zero factor property. So if you see or if you hear me say that, it's the same thing. Different books use different names for this. And so I grew up learning it, the zero factor property. Our textbook calls it the zero product rule. They're the same thing. So don't get too worried if you hear one thing and you're like, oh no, what is it talking about? So this is used on quadratic equations. So just as an overview of quadratic equations, which it's an equation where you have your exponent. The highest exponent that you see is 2. So when we were FOILing and multiplying out polynomials last week, or 2 weeks ago, we were doing a lot of stuff. We were creating quadratics. And when we're factoring trinomials, we're factoring things with an exponent of 2. We're factoring quadratics. We don't usually call it a quadratic until it's an equation, which means that you have it equal to something. So the word quadratic actually comes from Latin. I had to look this up because when I hear the word quad, I think 4. Because that's just how it's used today. But it actually comes from Latin, where that means made square. Squares have 4 sides, so that's why the word quad is associated with 4 today. But if you think about it, these are things with exponents of 2. They are squared, so that's where the name quadratic comes from. So it does make sense that it's called a quadratic once you understand where the name comes from. If you were just trying to, figure it out based off of what you know about words today, it wouldn't necessarily make sense. So these are also called second-degree equations. And the degree of the polynomial, we talked about that when you're learning about polynomials. That's the highest exponent. So second degree means the highest exponent's 2. So we're going to be focusing on quadratic equations. So there are lots of different ways to write these. Standard form is where it's ax squared plus bx plus c equals 0. So this is the form of the stuff that we were factoring last week. The trinomials were in this form, where you basically have something squared plus something x plus a number. There are other versions that are still quadratic. So you can see it with just ax squared equals 0, ax squared plus c equals 0, ax squared plus bx equals 0. And all of those are quadratic because you can see there's an exponent of 2. The 2 bottom ones, these don't look quadratic, but they still are if you were to multiply it out. And the 2 bottom ones are the types that we are going to be solving. Those are the kind that you solve using the zero product rule. So if it's something like an x times something else with an x, or you have something with an x times something with an x, those are the 2 forms. And these are the type of forms where they're factored. So when we were factoring last week, we would get trinomials and turn it into something times something else. Once it's factored in factored form like this, that's where we can use the zero product rule. And that's why it's also called the zero factor property, because it involves things equaling 0 and involves things in factored form. So that's why that other name is also used. The zero product rule comes from the fact that you're multiplying, which the word product means multiplying. So you're multiplying things and it's equal to 0. So that's where this name comes from. So the rule itself is actually very simple. It basically is if a times b equals 0, then a equals b, or a equals 0, or b equals 0. And it comes from the fact of what we know about multiplication. If you multiply a number by 0, your answer is 0. So if you have two numbers that equal 0, one of those numbers has to be 0 in order for that to be true. It's possible they are both 0. It could be 0 times 0, but it could be 0 times 2. It could be 2 times 0. And so this zero product rule basically says we have these two things that they're multiplying and equaling 0. We don't know what the two numbers are, but at least one of them has to be equal to 0. So either A is 0 or B is 0, or they both could be true at the same time. They both could be 0. That's what this is saying. And so we're going to be using this because we've got these things, we have something times something else equals 0. And so that will allow us to separate two things multiplied into two separate equations that we can solve. So the steps for solving using the zero product rule are actually pretty simple. So you've got something that's factored and set equal to 0. So again, our two forms could be something like this, or maybe something like this. You could even have numbers in front of there. But you basically have things multiplied by each other and equal to 0. And you set each factor equal to 0 to solve. So each part separately gets its own equation. So like in this first one, we would say x equals 0, and then we would say ax plus b equals 0. And then you get two equations that you solve. Second equation, you would x plus c equals 0, x plus b equals 0. And the third equation, you would have ax plus b equals 0, cx plus d equals 0. So for each of these, we are creating two separate equations that are linear, because all we have to do then is solve for x. And so because we've got two equations, we're going to have two solutions here. So quadratics have two solutions. The number of the exponent is the number of the solutions you're going to have. And so you solve these smaller equations, and that gives you your final answer. So we will start with this example on the left. We've got x plus 3 times x minus 1 equals 0. So this is in one of the forms you see here. And so you take each parenthesis, each set of parentheses gets set equal to 0. And when you do that, you can leave off the parentheses. So this gives us x plus 3 equal to 0. And it gives us x minus 1 equal to 0. That's what the zero product rule is saying we can do, is that you've got these two things multiplying to 0, so you can separate them out and each individual thing is equal to 0. We usually have the word or in between here. And once you've got that, then you just solve for x. So the first equation on the left, you subtract 3 from both sides. And on the equation on the right, we're adding 1 on both sides. So I usually try to work both equations at the same time. So on the left, we get x equals negative 3. And on the right, we get x equals 1. So those are our two answers, negative 3 and 1. And we usually write our answer in set notation, where you just basically, you have the in between the curly braces, and you just separate them by a comma. So you can say curly brace negative 3 comma 1, and the order doesn't matter here. So you could also put 1 first and then put negative 3. You could also write your answer as x equals negative 3 comma 1. So you can also write it where you just have x equals and then you put both answers after that separated by a comma. Or you can write them separately, x equals 3, x equals 1. So there are multiple ways to show your work. I believe that the curly braces is how our textbook and Connect Math shows it. I'm actually going to briefly log in right now and double check so that I can make sure that I'm showing you guys the proper way to answer, to put in your answers, because I don't want to tell you the wrong way and then have you get it wrong because you didn't put it in, you know, correctly. Just give me a moment while I open this up. Yes, so this is just the first on the factoring. So they already give you the curly braces, so all you have to do is type your answers in here separated by commas. So that's why there's this right here to give you commas. So you don't have to enter in the curly braces, they're already there for you. All you have to do is put in the numbers separated by commas. So any questions on this first example? Okay, so let's look at this example, the second example on the right. We've got -1 times x minus 2 times 4x plus 7 equals 0. So this looks very similar to what we had on the left, but we've got this number in front. The zero product rule only really matters with things with variables. So the -1 doesn't really matter. If we followed the rule, you would set each thing equal to 0. So you would have -1 equals 0, x minus 2 equal to 0, 4x plus 7 equals 0. And the -1 equals 0 doesn't mean anything. So it doesn't really count because there's no variable there, that's just a false thing. So if you have just a number by itself, you don't really have to worry about that when you're using the zero factor property or the zero product rule. You just focus on what has the variables because that's what we're trying to do. We're trying to find what are the value of the variables. So we have x minus 2 equal to 0 and 4x plus 7 equal to 0. And so we're going to solve both of these equations for x. So we were going to be adding 2 to both sides for the first equation. And the second equation, we're subtracting 7 from both sides. So for equation 1, we get x equals 2. So we have one solution. The second equation, we get 4x equals -7. So we're not quite done because we want x. We don't want 4x. So we just have one more step that we need to do, which is to divide both sides by 4. And we're going to get a fraction, and that's completely fine. We get x equals -7 over 4. So when we give our solution, you're going to be like if you were to type this in, you would have 2 comma -7 over 4. Like I said, the order of the two numbers does not matter. What matters is that you have the correct numbers with the correct sign. Are there any questions? Okay. So here on the left, we've got x plus 5 times x plus 5 equals 0. And on the right, we have x times 4x minus 3. So The one on the left, this is an interesting one. So we set each factor equal to 0, and notice that they're exactly the same. X plus 5. So we're basically solving the same equation twice. This is a very special type of problem. So when I solve this, I'm subtracting 5 from both sides in both equations, which is identical. And so we get an answer of 5, or I mean not 5, negative 5, and an answer of negative 5. Whoops, I keep missing my negative. So when you get the same number twice, they're the same number, this is called a double root. So double because there's two of them. And then the term root is actually used for answers of a quadratic equation. Sometimes we call them roots of the equation. So we still have two answers. They're just the same number. So when we write our final answer, you're only writing one number. You don't need to write it twice. You just have one number that you're writing. And so it looks like, oh, we've only got one solution. We're supposed to have two. We do have two. It just showed up more than once. And they're identical. So sometimes that happens where you end up with the same number twice. And so you only have one number that you have to write in. Now the example on the right here, we've got x times 4x minus 3 equals 0. So I like this one. I like when things are in this form because if you just have x by itself out there, you already have one answer. You get x equals 0, you don't have to do any solving. So these are really nice. And then the second one, you have 4x minus 3 equals 0. So then you need to solve that equation. So it's like you're doing half the work for these types of problems. So we start by adding 3 to both sides. That gives us 4x equals 3. And then we divide both sides by 4. And that gives us x equals 3/4. So when you write your answer, you do have 0, and then you have 3/4. So it's not like you got no answer for that first one. You did get an answer. You get an answer of 0, and then you get 3/4 for the second. Are there any questions on either of these two examples? Okay. So all of those examples were quadratic, where we had two answers. Sometimes you see something like this, where you have more than two sets of parentheses that have things with x. So we have 3 sets of parentheses here. This is what's called a cubic equation. It's got an exponent of 3 if you were to multiply everything out. Even though this is not a quadratic, the product rule, the zero product rule still applies. So it doesn't matter how many things you have multiplied together, as long as they're separated by parentheses and multiplied like this, you can use the zero product rule. So we ignore the 4 because the number, if it doesn't have a variable, it doesn't matter. So we have 2x minus 1 equals 0. X minus 10 equals 0. And then x plus 7 equals 0. So we actually are going to have 3 equations to solve here. So we're going to have 3 answers. And that's okay. We can still use the zero product rule here. So the first equation, I'm adding 1 to both sides. Second equation, I'm adding 10 to both sides. And the third equation, I'm subtracting 7 from both sides. So that gives me 2x equals 1, x equals 10, and x equals negative 7. So that first equation I need to keep going on. I'm not quite done. I need to divide both sides by 2. And so we get x equals 1/2 there. So now I've got my 3 answers. 1/2, 10, and negative 7. All 3 of these numbers work in this equation. And so we have 3 solutions. Are there any questions? Okay, so I've got one more example here, and I want you guys to kind of work this one along at the same time. You know, see if you can see what answers you get, type them into the chat. This one we're going to have 4 answers because we've got this first part that has an x, so that's negative 3x equals 0. We've got the x minus 1 equal to 0. We have x plus 7 equal to 0. And then we have 3x minus 5 equals 0. So this ends up having 4 answers because there's 4 separate things with x's that are getting multiplied. So I want you guys to try to solve this one, and then you can just type in the chat what your answers are. And I'm going to solve it, but I'm going to solve it silently here so that way you can work on your own. And then we'll kind of see, you know, what answers you got and are they right. So you can go ahead, kind of work on that. I'm going to start doing these backwards from right to left just because. 0.175 thirds. You beat me to it. That is the same thing that I got. So when you solve the negative 3x equals 0, when you divide both sides by negative 3, you get 0. Then x minus 1 will give you an answer of 1. X plus 7 gives you an answer of negative 7. And then the 3x minus 5 gives you an answer of 5 thirds. So when you've done enough of these, you may notice that there's sort of a pattern with how you get the answers. And so when you do enough of them, you don't even really need to show your work. You can just get to the answer. Because if you notice, all of them are the opposite sign. So if it was an x minus, your answer is positive. If it's an x plus, your answer is negative. And all of your answers are the number part divided by the part in front of the x. So So like the 3x minus 5, it's going to be positive because that's a negative, and then it's 5 over 3. If there's no number in front of the x, it's just over a 1, so it's just the whole number part. And this holds true for all of these. So if you look at it here, the 2x minus 1 gave us a positive 1 over 2. X minus 10 gave us an answer of positive 10. X plus 7 gave us an answer of negative 7. So if you look at the pattern and you see how it's working out, you can get your answer without even showing any work because you can kind of just do it in your head. That is actually what I did when I was learning how to do this because I didn't understand the process. So when I was learning how to do this, I looked at that pattern and that's how I always got my answers, but I didn't know why it worked. I just knew that that's how it worked. But it works because of the zero product rule, as you set each thing equal to 0 and solve. So I don't recommend you skipping this in your notes. It's good in your notes to write down every step. But let's say you're on a quiz maybe, and you can do it in your head, you're running out of time. You know, maybe you can use that shortcut. And then maybe like once you took the quiz, you can fill in those missing steps. But these are nice because you can just kind of look at it and you can see, following the pattern, what the answers are going to be. Are there any questions? Okay, so that's the zero product rule or the zero factor property. The next part to solving quadratics is you need a factor first to put it in this form. So I have another video in the class that's called solving quadratics by factoring, and that's the next step, is that you have to first factor it so that it's in this form so that you can continue. So we've basically learned how to do half of it. And then that next video will teach you how to combine the factoring from last week with this stuff so that you can solve them in lots of other different forms. So thank you guys for attending. I want to pull up my calendar here because with the holiday, next week, Thursday, when we would normally have our live, is Thanksgiving. So obviously, we're not going to have a live that day. So it is going to be Wednesday at 3 p.m. So I've moved it to the day before. And then because I'm going to be with family, I'm just trying to keep my evenings free with my family. So I'm putting in during the day. So that's going to be next Wednesday at 3 p.m. I will make sure to send an announcement early enough so that way you guys know, but just a heads up that it won't be on Thursday because Thursday is Thanksgiving. So hopefully you guys get to spend time with family, that you travel safe, and just as a heads up, I will be traveling this weekend and then the following weekend, so I'm going to be spending the week with family. So if I'm not as responsive as normal, that's why. I'm still going to be working, you know, but I'm going to have to juggle family and work. So just giving you a heads up, so that way you're aware and you're not like, what happened? But I am going to be, you know, making sure that I'm checking my email and everything regularly and doing everything that I need to do. So you guys have a great night, and hopefully I'll see you next week, Wednesday. And if you can't make it, then hopefully I'll see you the following Thursday at our normal time. So bye. Thank you for coming.